Okay. So let's go through what all we did. So first thing was we saw about the fundamental characteristics of cloud and what is cloud. And these are some of the features that we discussed about, that is on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. I've already explained what all these are. Then we studied about different types of cloud, that is public cloud, hybrid cloud, private cloud, and serverless. We also studied about various services that are provided, like infrastructure as service, platform as service, and software as service. These are some of the networks and data centers available of Google, and we'll be studying more about it in the further session. Then we discussed about some of the compute services that Google is offering, like Compute Engine, Kubernetes Engine, App Engine, Cloud Functions, and Cloud Run. We studied all of these in detail in the previous session as well. We also studied some of the storage services that Google provides. Actually, this was left to discuss. So these services will be doing it today in the further session. Then these are uh, some of the big data and machine learning services that Google offers. And then we continued with various ways we can connect with Google Cloud and the various attributes of project and how we can access the cloud console, how the billing works, and so on. Various features of Cloud Shell and different other ways to connect. And we studied about various compute engines as well. Sorry for that. Then we studied about all these functions and how cloud functions work. And we studied about containers, cloud run, then data centers, Kubernetes, and this is where we ended on Kubernetes. So in the further section, we'll be studying about GCP storage services. Okay, so we'll be starting with the storage services. So, what is GCP storage services? As we have seen there are certain services that Google Cloud provides, and these are some of them. We'll be studying in more detail about them. So, the first one was memory store. So, memory store is the in-memory storage that we have, and it is a managed in-memory data store which manages the Redis and Redis data store and memcache. Then this was the memory store is a type of in-memory storage. Then we have relational storage where all the data is stored in the relational manner, as we all know regarding MySQL, then SQL Server, PostgreSQL. So all the SQL related things are handled by Cloud SQL, where you can use the SQL queries as well. Then another form that we have in relational storage type is Cloud Spanner. Now, what Cloud Spanner is, it is similar to how Cloud SQL works, but then this Cloud Spanner, it provides high scalability, that is in form of horizontal scalability. So what is it is so Cloud Spanner, it helps you to uh, distribute or like manage your database across various multiple locations, geographical locations that are present. So that is what spanner is. It is on a global scale. So that is another form of relational storage. Then we have no SQL storage types, that is Firestore and Cloud Bigtable. So what is Firestore is, in Firestore, you have a serverless scalable document store. So Firestore is basically a document store which is present, and it which is present. And then we have Cloud Bigtable. Cloud Bigtable, it provides low latency, scalable, key value, and wide column store. So what low latency is, there is less delay and you can scale your data. And these are types of no SQL storage. So what Firestore is that it is a NoSQL document store database, and it lets you store, sync, and query data that is used for mobile and web apps at global scale. Similarly, what Cloud Bigtable is, that it is a populated table, that is it stores a large amount of data, and it has multiple number of rows and columns that stores your data, and the data stored is in terabytes, petabytes, and so on. Then we have is the analytical type of storage, which is which is for the enterprise data warehouse, and it is known as BigQuery. So BigQuery, it fully manages your enterprise data warehouse, and it helps you to analyze data. So it has built-in features which can help you in analysis. For example, you can do machine learning, you can do business intelligence, and so on. So this was regarding BigQuery. Then we have cloud storage. So what cloud storage is, that it manages and stores your unstructured data. So whatever unstructured data you have, like objects and blobs and everything, you can simply store it in cloud storage. Then we have persistent disk. Now, what persistent disk is, it allows you features like local VM file storage. So, in persistent disk, you have high performance and reliable block storage where you can store like information and data regarding VM instances as well. And you are easily able to deploy and scale your data using the persistent disk. So, and next we have is file store. So what file store does is, your file data is shared among among the servers and applications. So that is what file store is, that we have lift shift apps requiring file. That is it has shared file access. So I hope these are clear. So these were some of the storage services that Google provides. Any doubts? So this was all regarding storage services. Now moving on to what are the common use cases for cloud storage. So cloud storage can be used for storing the content and for the delivery of content. It can also be used for analysis and for general compute tasks. And it is also used for backup and archival storage. So these are some of the use cases where cloud storage is used. Moving on to the types of data, we have two types of data, structured data and unstructured data. So in structured data, there is a particular structure to how your data is stored. For example, in the form of rows and columns. But for unstructured data, there is no particular structure. It can be voice transcriptions, or it can be reviews, ratings, messages, and so on. So these are two types of data, structured data and unstructured data. Then this is a flowchart of how you can decide which storage option you can use for according to your needs. So this flowchart displays that if you depends on how your data is. So it asks if your data is structured. So if your data is structured, then you can use these like services. But if your data is not structured, then as I mentioned, that unstructured data can be stored in cloud storage. Now, what if the data is structured? Then we have two options. Then we have the option we have is your workload analytics. That is, do you want to use it for analysis purpose? If yes, then you have two options, that is cloud bigtable and bigquery. Now even which one to use depends on the latency. So if you need low latency, then if you need like updates or low latency, that if it is yes, then you can use cloud bigtable. But if it is no, you have chances of using bigquery. So this is what the flowchart displays. But what if your workload is not on analytic purpose? Then you have to see if your data is relational. If it is relational, then you can go for two options as mentioned, that is Cloud SQL and Cloud Spanner. But if your data is not relational, you can use a data store. Now, if whether to use Cloud SQL or Cloud Spanner, as I said, depends on scalability. So horizontal scalability, I've already explained what horizontal scalability means. So if you want your data to be stored on a global scale, then you might use Cloud Spanner. But if it can happen within the region or zone, then you can use the Cloud SQL. So this is what the flowchart states, that what are your needs, what are your workloads, and how you can use which type of services to store your data. I hope this is clear.
What is
If
latency?
you all have doubts, yes, yes, you can say.
What is latency?
So latency basically describes the delay of the tasks that are performed on your side. So latency is the delay that occurs. Then these were all the storage services that Google was providing. And there are similar kind of services offered by other cloud providers as well. Moving on to GCP security and IAM. So there are various security and identity and access management features and services as well, what GCP like offers. Now this chart shows the security responsibility of your at your end as well as at Google's end. So everything in blue shows that all this is customer managed, and customer manages the security related issues regarding their resources and services. But the yellow ones state that Google manages the security for these options and services. Okay, so first one is on premises. So on premises, as I mentioned, that it doesn't come under cloud. You have all your data centers and servers and everything available on your premises. So that is what on premises means. So naturally, all the workload and everything comes under your task. But if you are using infrastructure as management, then it happens that like the services like hardware, storage, encryption, OS, data, everything, all such things are provided by Google. So they are providing security for those infrastructures and services as well. But the deployment that you are doing and the content that you're uploading, the web app and everything is under your control. So you have to manage the security in that case. Moving on to platform as a service. Now, as you all know that as and when you move forward, your responsibility is lowered at each stage. So as and when you move forward, even the securities that you have to handle decreases as you go on in this chart. So moving on to platform as a service. Now here, as you can see that now you don't have to handle securities for identity. That is something which is included in platform as a service by Google's side. So what you have to manage is the first few services that you are handling. Moving on to managed services, most of it is handled by Google as they are providing the infrastructure and other services. So even the security is managed by Google, but the data that you're providing and the uses that you're making, all the security is to be provided by you. So the main conclusion of this chart is that whatever resources you are managing in the cloud, you have to ensure the security of those resources. And you can do so by various other services which are provided by Google. But the thing that you are not managing and is managed by Google, Google is also ensuring the security for those services and infrastructure. I hope it is clear. Any doubts, you all can keep messaging in the chat box and I'll be like solving it as and when we go ahead. So as I said, that data access, what data you are providing, what are the bugs at your end in your application, all these and the security related to that is to be the customer's responsibility. Moving on to identity and access management. So, what is identity and access management? Identity and access management let us know who can do what and who can access what kind of resources using their account or their platform. So that is what identity and access management states. That is, it lets the admin authorize who can take actions on which resources. So that is what IAM is. Moving on to who can apply for IAM policies. So for Google Cloud, those are the Google accounts that we use or the cloud identity user. Then we have service accounts that the Google is using. The group Google Groups and various Google Workspaces account that we use. So we can access our platform and our console using all such types of accounts. But yes. So these are what we can do. So these are the who from IAM, that is who can access the cloud platform. Similarly, who now we have seen who can who can access, but what can they access? What are resources they have access to? What actions they can perform is defined and identified about the identity that we have. So there are three types of IAM roles. First is basic, then we have predefined, and then we have custom. So what basic roles does is the roles those are the basic roles that are available for the user. That is, you are the editor, you can own your resources, you are the editor, you can view your resources. Those are the basic kind of actions that you have already you already have access to being the user. Then we have predefined roles. Now what predefined roles is, it has fine grained access control as compared to basic. So not everything that you can do using a basic identity can be done using a predefined identity. So it is a bit so like you are a bit restricted in the predefined area. Similar to moving on to custom roles, those are tailored permissions. So here these are more specified and specific regarding the resources and what access you have. So basically in basic you get all the basic and default access that you are supposed to receive. In predefined you can only access some tailored and fine grained resources that is made available for you to access. And in custom you can access more limited amount of resources and only those who for which you are given access for. So these are the three types of IAM roles that we have. For example, I can say that if I create my account on Google Cloud, not the one which I'm using on Skill Boost, but if I actually create my account on Google Cloud using my credit card and everything, so what I get is the basic set of things that I can do. But if I am using it through an organization or an entity, so they have given me only certain kind of access to certain kind of resources that I can do. Similarly, on custom roles, the like access and uh, the what we can access and the resources are more limited of what is defined for, of what is like arranged for you. So these are the three examples for three types of roles that we have. Now here we are looking more into the into each roles. So as you can see that in predefined roles, you can apply to a particular Google Cloud services. So that is, for example, you can apply for compute engine resources and other folders and organizations. So you are doing it under an organization or a folder. So that is what predefined means. As you can see, for predefined, you have fine-grained permissions. So like you can delete, get, list, set machine type, start and stop. So these are some of the actions that you can perform if you are if you have or are performing an instance admin role. So this is an example of it. Similarly, for custom roles, you can see that the actions that you can perform have been limited, and you are operating as an instance operator role. And you can compare these two and see that certain actions have been disabled for your identity. Next, we will be talking about service accounts, that is server to server interaction. So how servers interact between them. So for server to server interactions, firstly is you should have that kind of identity, and like the services that you use and interact with authenticate each other before interacting. Similarly, there are control privileges by resources so that applications can perform actions on behalf of authenticated end user. So you like all the privileges that you have are controlled, and only authenticated users can perform those actions, and the authenticated end users have also set some privileges for others. Now, what are server to server interactions identified as? They have they have email IDs like this, like gserviceaccount.com and apps.gserviceaccount.com. So these are some of the identities identifying the service accounts that we have. So this is how the service accounts control the server to server interaction. That is, everything is done in an authenticated manner, and you are provided certain privileges and certain actions that you can do. So this was all regarding the IAM and security of Google. Now moving on to next topic that we have for today is Google Network. We'll be also discussing about GCP networking and cloud operations. What is Google Network? As I mentioned that we have various resources and servers available at various locations around the earth, and so these are some of the data center locations that we have, and they have like the all the regions have three zones for now, and those in triangle are the regions which will have three zones in the future. So this is the basic map showing how many regions are available, how many zones are present, at what locations we have the data centers, and so on. So this is generally how you can see what resources are accessible and available in certain regions. So this is what it shows. Moving on to Google Cloud Networking. So in Google Cloud Networking, we have the first thing that we have is virtual private it is the virtual private network that we have, and it is a software defined network. So what is VPC? It is basically a virtual network which is kind of similar to a physical network, and it provides connectivity between various VM instances, and so on. It also connects like on-premises network, and doing that, it uses VPN tunnels and VLAN attachments that we use. We'll be discussing more in depth in the further slides. So this is what a VPC does. So what VPC does is it allows deployment of IaaS resources that everyone knows what IaaS is. Then it does not have IP address ranges, and it is global. That is, VPC is a global network that we have, and it contains subnets. We'll know more about subnets in the further slides. So this is how like a diagram of a VPC network looks like. So it is a virtual version, as I mentioned, of a physical network, and like VPC is a global resource. Now here you can see that there are two regions present, US West one and US East one. So how they are interacting with each other is what is shown in this diagram. You can see at the lowest level there are multiple like VMs that are present, and they are present in various subnets, as you can see. And how are subnets in the two regions like interacting with? They are using VPC routing, and this VPC routing is connected to the internet gateway, and it is connecting to the internet. Now here, on the other hand, we have on premises, which is connecting to a VPN gateway, and that VPN gateway is connected to various like regions that we have in the VPC network. Now, what on-premises in this case means is not the data center which is available at your end, but on-premises here means the device that you are using to access your Google Cloud. So that is what on-premise here means. As you can see, there's a device which is like drawn here. So this is how a VPC network works. That is, on premises is connected to a VPN gateway. On the other hand, internet is connected to the internet gateway. Then we are using VPC routing to like route between these VMs. And each region has various different zones. Each zone has various different VMs that are running. And those VMs are running on various subnets that we have. I hope this is clear. Any doubts, keep posting messages in the chat box. Next, moving on to subnets. So subnets, they are regional, and they like extend across the zone. So same region, uh, like subnets are extending in the same region and across the zones in that region. So you can see in this diagram, this is the same previous diagram, that or we have VMs under various subnets here. So we have subnet 1, subnet 2, subnet 3, and so on. So what are subnets? They are basically, they contain certain range of IP addresses in the VPC network. So that is what subnet is. This shows how like the network behaves within a project. So you can see that we have this two regions, that is Asia East 1 and US East 1. So the VMs in these two regions, like two different regions, are connecting and interacting with each other using a private IP. But the VMs in the same region, they are connecting with each other using like using internet and using the public IP. So this is what basically a project looks like, that and this is how the interaction is happening, and the network behaves in the VPC. You can see that even in the same region, We can have like various VPC networks like 1, 2, 3, 4, and so on. Then we have like two types of subnet modes. First is the auto subnet mode, and the next is the custom subnet mode. So in auto subnet mode, what happens is you already have a subnet that is automatically created in each region. So this auto subnet mode, things are done automatically. But in custom subnet mode, there is no subnet which is created automatically. Like it has to be created by the customer end or so on. Then we have auto subnet mode that it has certain kind of predefined IP ranges. But for custom subnet node, the subnets and IP ranges are like they are defined during if we create it then. So these are basically automatically defined and these uh, are supposed to be defined. Then we have as it is a auto subnet mode, we have default firewall rules for that as well. But if you are creating a custom subnet mode, then you will have to create certain firewall rules. There are no default firewall rules that are there. Then auto subnet mode, they are expandable to like /16, and here they are expandable to RFC 1918 size. So some of the use cases are that here they are used for testing and proof of concepts, and here they are used for production. So these are the differences between auto subnet mode and custom subnet mode. Basically, certain tasks are done automatically in auto subnet mode, and those are not done automatically, or we have to create them in the custom subnet mode. Then, as I said, that the VPCs are made of subnets, and subnets are on the regional level, and they are configured with private IP address ranges. Now, IP addresses, they are used for internal network communication. That is between the like within the network that is defined, you can use those IP address, and each subnet comprises certain kind or certain range of IP address. Okay. So here this is how like an IP address looks like, and each octet is of 8 bits, as you can see it is mentioned here. Now since we are using /16, these two are freeze. That is, here you won't change any like values, but these values will change as and when which IP you are using. These are some of the IP address ranges and how many IP addresses they provide, and each like range has its own particular set of IP addresses. Then we have public and private IP address, and what is the difference between them? So we have internal IP and we have external IP. So cloud external IP addresses are the external IP, and internal IP they are like connected through the internet. So internal IP, it is allocated from subnet range to VMs. So the VM subnet ranges that you have, it is allocated by that. And external IP can be assigned from pool or reserved. So from the reserved state of IPs that are there, from that external IP will be assigned. But from the ranges that are available for VMs by DHCP, that can be within the internal IP. So that is it. And so the and about the billing that happens, the like internal IP, the billing is renewed every 24 hours, and for external IP, billing when you are not attached to a VM, then you are billed. Like yes. So here in internal IP, VM name and IP is registered with network scope DNS. That is, these two these two entities or attributes are registered during for the internal IP. But when you are using the external IP, you don't need to Like VM does not need to know what the external IP is. It is mapped to the internal IP. But here VM, like as you can see, VM is mapped for the internal IP, and for external IP, VM does not need to know the external IP. Then we have the primary products that are there for Google networking. The first one, as we discussed in detail, was virtual private cloud, where we are managing the network for various resources. Then we have is cloud load balancer, that is we are managing the traffic between like different regions, and it has worldwide auto scaling. That is, of all the regions that are present, you can do auto scaling and load balancing in those regions. Then we have cloud CDN, that is content delivery network. So how the content is delivered across the network is what cloud CDN handles. Then we have cloud interconnect. So how cloud is interconnected within to various other services, and it is fast and the availability is also high for interconnect. Then we have cloud DNS. So we have a global DNS network for in case of cloud DNS. So these are some of the primary products that Google networking like offers and is there. Then we have like firewalls that are protecting the VM instances that we have. So how it is done, these are some of the key points. That is, VPC network functions as a distributed firewall. So uh, we have a distributed firewall which is protecting the entire VPC network, and the firewall rules are applied to the entire network as a whole. So that is what that is how the firewall is applied. Then we have like the connections are allowed or denied at the instance level. So what connections you have, and whether you are allowed to access or denied, all that is decided when you create the instance at instance level. Then the firewall rules are stateful, and there are certain firewall rules, like you can imply, uh, deny all ingress and allow all egress. So what ingress and egress is, we'll be seeing on the in the further slides. So as you can see in, so basically it means which is coming to the instances, and egress, that is which is going outside the network. These are some of the desired like firewall configurations that you can make while creating a firewall rules. That is the direction of the rule, what will be the source or destination of the connection, the protocols and ports of the connection that are allowed, then the action of the rule, priority of the rule, and rule assignment. So these are some of the desired configurations set for the firewall rules. So let's see what egress is, and the use case of egress. So here there are certain conditions, that is protocols, like these are the conditions, that is the ranges, protocols, and ports. And now what is allowed, what is denied. So if something is allowed, you get the egress is matched, and you can make transactions and delivery between. But if something is blocked and denied, then you won't be able to access the VM. So here, as you can see, egress, it is moving outside the Google Cloud network. So so here, as you can see, from like from VMs are protected by firewalls, and whether external host can access it or not, like implies to the conditions that are there and the actions that are allowed and denied. Similarly, for ingress, the the requests that are coming from external hosts and VMs to the VM that is there in the Google Cloud Virtual Network. So Here it was the destination that we are considering for conditions. Here we are considering the source CIDR ranges and the protocols and ports. Similarly, the allow option and deny options, whatever actions we allow and deny, will determine whether certain host and VMs can be can be able to network or connect with the VM present in the Google Cloud network or no. So this is what egress and ingress was all about. So as we are reaching the time, I will stop now and let's take some of the doubts if you all have them. Any doubts? Okay, what is unstructured data? So, unstructured data is basically a random type of data where there is no predefined structure for it. For example, if you are storing a data in a table, then that comes under unstructured data. But if you are not storing, but if your data does not have a particular structure, that is, your data consists of various types of information, like it consists of messages, voice, speech, and so on, and there is no structure defined, then that is called as the unstructured data. For example, you can see uh, if you see like YouTube, so YouTube provides various types of data. So it has videos, then it has short videos, then it has like certain kind of posts, certain kind of text. So that is what it has descriptions. So that is, it has multiple types of various kinds of data which has no particular like structure. So it is not entirely the example of unstructured data, but I hope you have basically understood what unstructured data is. So it is a data which has no proper structure, and it is uh, stored in the cloud storage in case of cloud. What is virtual machine and what is the work of virtual machine? So virtual machine is basically a machine that is created virtually. It is similar to what you have a device in front of you, but but it's like here in virtual machines it is created on some other machine, and the infrastructure and everything is not what you are actually having in terms of hardware, but you are having it virtually. So that is what virtual machine is. And how you can work, so basically you can do all the tasks that you do on a normal laptop or a device on your virtual machine, that is creating applications, storing data, creating web applications, and so on. I hope it is clear. Any more doubts? Okay. Yes. So here we'll be ending the meet, and the Gen AI, how to access the Gen AI subscription. I'll let y'all know through a recording that I'll be sending after the meet. And make sure that you are completing the labs. At least remove some time for y'all to complete the labs. Even in 1 2 hour, you can do multiple, like 1 2 hours, you can do a lot in the course. So make sure you get some time and do all the required courses that are there. Many of you all have already done more than four courses. So make sure after I send the Gen AI how to access, you all do the Gen AI course as well. So I hope the instructions are clear. The deadline to complete both the pathways is 20th October. So I'll be ending the meeting on this note. Thank you so much for attending. If any doubts, you all can feel free to ask in the group or on personal as well. Thank you, everyone. We'll be like ending the meeting now.